All right. Hi. IoT at home, the solution to all your spare time problems. I'm gonna, say sorry because I'm gonna be the guy who's gonna spend the next hour between you and beer. So I'm gonna try and make the most of it and not be too boring. For now, I have an echo effect. I don't know if that's good or bad, but so I'm gonna talk about hardware programming and not as much programming. There's not gonna be no code at all. I'm just gonna talk about why you should do it, and when you do it, what you should think about. And if you don't think about it, what's going to happen. Okay? Why am I not seeing the right type of slides? Give me a second. All right, so there we were. Okay, sorry about that. All right, so I'm going to talk about why we should do this and how we should do this. But, and there's a big but here, the Internet of Things is something that we all been talking about for a long time. I said earlier today that I do not believe that we're ever going to have one Internet of Things because people love their data. People make money from data, which means that nobody's going to give you their data because they're going to sell the data, which means that we're going to have a lot of Internet of Things. We're going to have like maybe the Oslo Internet of Things or the Norway Internet of Things communicating what Norway would like to sell to the Swedish Internet of Things and the English Internet of Things and so forth. But every one of us here that are developers will be touched by this movement. We will do hardware development. Customers will request that hardware will become a part of what we do. In the future, when we build like a business intelligence solution, they're going to want to have data from the physical world into their business intelligence to help them make even better solutions. So we have to learn this. We have to understand the implications of it. And one of the best ways to do this is simply building your own stuff in your own home. And that brings me to Todd. When I started talking, I wanted to talk about the Internet of Things. I wanted to talk about building countrywide networks where everybody, shares data and everything is awesome. Internet of Things. And everywhere I went, somebody sat in the front row and said, but what do you build at home? What about home automation? Because we love home automation, don't we? Who loves home automation? Everybody loves home automation. I love it. How many have more than one Raspberry Pi connected in their house doing something that automates their home or any hardware technology? Like 50%. I love it. Todd wanted to do that. Todd came to me after a talk. He didn't dare to ask a question up front, but he came to me after the talk and he said, hi, can I buy your beer? I was like, yeah, sure, you can buy my beer. And he said, I want to start doing this at home. I want to do this in my home. And I just given a talk of how to start doing stuff like this. And he said, but I'm married. And it turns out he wasn't just married. He was married to, so Todd is not his real name. I changed the name. And he was married to like the queen of decorating and stuff like that, and interior design and fashion and everything in his country. Like a blogger with 500,000 readers or something like that. I mean, good for Todd, but like he couldn't really do stuff in his house. His house was extraordinary, perfectly arranged. There is something that we call the WAF. How many people know what the WAF is? Everybody knows what the WAF is. It's the wife approval factor. I don't like the wife approval factor because a lot of my friends that are hardware developers have husbands. A lot of my female friends that are developers have wives. It doesn't work that way. So we started calling it the marriage interference factor. Which meant that you had to be married for this to work. So now we call it the spouse acceptance factor. And I'm going to go with that. So what this is basically, in short, what you can get away with in your home doing. But it also is a measurement of buy-in. If your wife or husband or spouse or whatever you have, rocking chair, doesn't like what you do, that dramatically limits the opportunity that you will get to continue doing it. And it will happen in the most sudden way. I'll tell you what, if you come home today and you say to your husband or wife or whatever, I'm not going to do like that, and I want to build automatic stuff. I want to automate this. They're going to be pretty okay with it because you like passion, right? You like when your family has passion for things. We like that. And we're going to be like so messy because it's a messy hobby. And suddenly you're going to appear that people go around to you and, you know, the lawn needs cutting. Have you noticed that? Isn't it a bit dirty in here? Should we cook together? Do you want to have a bath? There's many ways to not get people in your life to do things, right? We manipulate them. So, let me help you. I have prepared an exercise for you guys. Let's just practice that we all got this. Hands up. Awesome. Other hand up. Great. So, if you think that the picture I'm showing you is high spouse approval factor, raise your hand. Does this picture have a high spouse approval factor? By the way, this is my office in my previous flat.
That's what my wife's desk looks like.
We have found the exception. All right, this one then. I agree with you. This one then. Now, very common mistake. If it looks cool but isn't practical, usually it isn't a high spouse approval factor. It also has to be practical and look cool. Last picture. Good. Okay, I think most of you got this. Awesome. So why should we care about what our family thinks? Why should we care about our loved ones? Screw them, I say. No. Actually, if you want to do stuff at home, how many of you are gainfully employed and works 40 hours a week or more? How much time do you actually have for this? Yeah, 0. But your spouse can become the most interested and motivated product owner you have ever met. And you need that. Because you will have so many ideas. You get a fraction of knowledge. And you will have so many ideas. I get new ideas every day. And I'm very thankful to have my wife, my lovely Therese, because she keeps me grounded. When the Internet of Things was new, when it was just, booming and we were talking about it everywhere, we started talking about things in 1997. I'm talking about like 2012. But anyway, when it wasn't what it is today, I was imagining a fridge. Think about a fridge that knows how much milk we have. If you and I were married, we could go shopping and we would know exactly how much cheese we have, how much milk we had, how much salad or whatever you have in a fridge. And I said it to my wife, and she was like, nah. Like, why not? This is amazing. This is amazing. This is amazing. No, it's not. It is. Okay, tell me why it's amazing. So I started, well, think about this. Like I like milk in my coffee, and we don't have milk for many other things. So it's often out because I forget to buy a new one. Now I can get like push notifications that would tell me, buy milk. And she'd say, how would that work exactly? And I said, well, perhaps, because I wasn't prepared for that question. I don't know. And I said, maybe with scales? You could put scales beneath things and you would know like how much to weigh and you would get the proportions of the things. And she's a bit of a drama queen. She walked over to the fridge, she opened it up and showed me this. And she told me, in my own language, which is geek, a fridge is a stackable storage space. It is true. It is true. We stack things on top of each other in a fridge. We have no idea where things goes. We just throw it in there. If we're going to have a party, we have beer. If it's normal, if it's a family dinner, we have food, we have potatoes, we have meat. And we need people that tell us this. My first attempt to build this product would have been a scale. And it would have sucked. But because I have buy-in from my family, I have a motivated and smart product owner who cares about the end result. And you could have the same if you consider building good products when you start building things for home. Which leads us to, why on earth would we do that? I'll tell you why. Because we are smarter. We are smarter than Google. We're smarter than Microsoft. We're smarter than Facebook. We are smarter than most people. Because when we see a smart lamp, we realize the potential of it. But when Google sees a smart lamp, they try to sell it to 1,000 people. But we see our needs. There is impossible to sell a huge group of people the same IoT solutions because our homes are different, our needs are different. What we do is different. We, who are a collective of people, can figure out how this works. But I do not think that a bunch of people that sits with the same people 12 hours a day writing code will ever crack that code. You need to be in the real world to understand how this works. Also, by the way, this is a smart lamp, and I hate smart lamps. So I just got to say this. This is a rant. Sorry about this. Give me 2 minutes. Smart lamps are horrible, horrible, horrible inventions. Why? Because you sell lamps that are connected to with everything in it. Like you take 240 volt AC, and then you turn it down to like 5 volt DC to be able to have a microprocessor inside your light bulb with a Wi-Fi connector. How dumb is that? When we can just hook up one Wi-Fi connector, one thing, to control all our lamps. Let's change that. It's just a silly idea. I don't like it. Ugh. But what about data? I told you previously, data is valuable. Why do we give it away? Why do you give your data away? Would you tell me where you were yesterday? For free?
No.
You wouldn't? Suspicious. If I gave you 1,000 Norwegian crowns, would you tell me where you were yesterday?
Possibly.
Interesting. So we determined that data has a value to you. But why do you constantly give your data away? You have Facebook, Twitter, something like that. We give our data away. I give my data away every day for free. To reserve a software, to receive a software as a service solution, I give my data away to somebody who stores it and doesn't even let me access it. There's no Facebook API. Maybe there is. Well, there is a Facebook API. Sorry about that. But there's no API where I can do like smart searches for my data that's just me. I can do smart searches towards the data that Facebook chooses to show me through their API. So that's also one of the reasons, if we build it ourselves, we can be the first frontier of data. We can store our own data, and then we decide what we want to share with the outside world. Make sense? And your brain gets smarter. This is, the Internet of Things is going to be a thing. Probably not what we think it's going to be, but it's something is going to happen with it. Something is going to become of the Internet of Things. And we might as well now start understanding electronics and stuff like this for the Internet of Things. Because if we don't, we're screwed. Other developers are going to be better than us, smarter than us, quicker than us. Are there any web developers here today? How many of you do not know JavaScript? When I started in this industry, there were web developers who told me, "Now, I don't need to learn JavaScript." They are no longer gainfully employed. All right. So I'm going to tell you about the first project. I just bought a house, by the way. I'm going to tell you about the first project I did and why that also is the reason to why we should build stuff. And then I will stop nagging you about why you should build stuff. So this September, I had the happiest day of my life. I bought my dream house. I moved there with the woman of my dreams, my beautiful project manager. And I suddenly had a place to do all those projects that I had envisioned in my mind. I'm going to build this. I'm going to automate that. I'm going to fix these things. But apparently having a house means that you have to mow the lawn and stuff like that, so I haven't built that much. Until one day, my phone rings in my office. Yeah, it's Carl. What can I do for you? Oh, hi, honey. What? No, I didn't get the mail. Oh, you got the mail. Awesome. No, I didn't see the heating bill. How much? 6,000 Swedish crowns? What did you do? So I had a 6,000 Swedish, almost a 600 euro heating bill. It was November, fine. But I was shocked. Why? Why was it so expensive? So I started thinking, okay, what is the reason behind this? Okay, what changed? Okay, so in June, it's just cold showers, just getting clean. But now we take warm baths and warm showers. Maybe it's the shower that is the most expensive part. Maybe it's the bath. Maybe it's the stuff that actually costs a lot of money. So I decided I want to figure this out. I want to have something that tells me how warm or cold is my shower, how much does every shower cost me. So I installed a humidity sensor in each of our showers that would tell me if a shower was running or not. I installed sensors. I installed a webcam on top of the reader for water, how much water we used. And I used an API. Yeah, I know, but it's analog. What am I going to do? OCR reading works. It's a technology. All right. So I installed a webcam above the analog reader so I can see how much water was being consumed before, during, and after the shower. And then I can make an estimated guess how much water am I actually consuming. And then I needed to figure out how much is the heating of that water costing me. That actually helped because the heating that we're using, we have a heating system that's delivered to the house. They pump hot water into the house. They actually have an API, so you can just hook yourself up to it, and it will tell you. So I put all this stuff together just to find out that we pay pennies for a shower. But I could never, ever have done this with any solution that you could buy in the store. I really, really wanted to do this. But it was impossible for me to figure out that no ready-made solution would have helped me do this. And I do not believe for a second that the ideas that you have, or any one of you here, is, in the long run, ready-made purchase stuff. And that's also one of the biggest reasons why we really have to start building our own stuff. So, I'd like to present to you my 4 rules to why building things with the highest spouse acceptance factor. These are also directly translatable to building products that actually people will buy. Number 1, administration is the devil. How many notes of this is? This is the DevOps release cycle. Love it. Learn to love it. If you have 1 hour every 3rd day, which is roughly what I have to do, you do not want to spend 1 hour figuring out how to get your latest piece of software published to your sensor system. You do not want to spend time figuring that out. Do it up front. Fix that piece of the puzzle. How do I do releases in seconds? I want to write code and test something. I want to have the DevOps solution. I want to have continuous integration. Release it. Extraordinary important to do this thing. The second most important thing with administration is that this also has to do a little bit about looks, and it's batteries. You're going to use batteries for a lot of your application. At least you want to use batteries for a lot of your applications. But how many of you actually do? So almost 50% had a Raspberry Pi or something like that running in your house doing automation chores. And one guy have battery-powered equipment. This is why. So Arduino is extraordinarily much less power hungry than Raspberry Pi is. So with a 9-volt battery of 1200 milliamps, it will last less than a day on battery power for a regular Arduino. If you use an Arduino Pro Mini that you don't modify or do anything, you can get up to 10 days. Would your spouse enjoy changing batteries on something that they rely on? Do you think you will get buy-in if you have to change the batteries every 10 days? What do you think? No, you won't. They'll hate it, and they'll stop using it, and it will just become a clunky piece of thing that they hate. Low. All right, but if we actually get an Arduino for Mini and modify it, we remove the power LED, we change to a much, much better regulator. That's all I did on the ones that I read about for this test, and I also duplicated this test. So I haven't actually tried that it runs for 3.5 years, because you get battery problems before that, but the math is saying you will get it down to 3.5 years in sleep mode. 3.5 years. Now I said sleep mode. How many people know what sleep mode for microprocessor is? Good people. So sleep mode is one of the most important things when you're designing a hardware thing that you don't want to have to administrate a battery for. If you want to have a long, strong battery time, you want to use the sleep mode of most microprocessors. Most microprocessors have this. Arduino has it, for example. Which means that at certain points, they will go into a very, very low power consumption mode, and at specific things like a timer or an event that triggers it, it will go back up, connect to the internet or whatever it does, and it will talk to devices around it and then go back to sleep. We do this to be able to actually have battery-powered devices. Another thing that's extraordinarily important if you want to have good battery power is the way that we communicate with our cloud services. So MQTT, Amqp, STOMP, and HTTP are just different names of different transfer protocols. There's a bit of a better analogy to show how they differ. The Mustachio Guide. It just shows us that Amqp is a bit of a mustache. MQTT is a little, you can notice it. Stomp is a big American man mustache, and this is HTTP. Don't use HTTP, okay? So MQTT is the one I use most frequently. It's extraordinarily small. It uses very little data, which is good. If you use like a SIM card or something like that, usually for an IoT device, you have 30 megabytes a month. That is a lot for an MQTT package that is just giving telemetry data. MQTT takes longer to connect to a service than HTTP does. But in the long run, you will save 5% battery using MQTT than HTTP. And you can send thousands more message than you can do with HTTP on the same amount of battery. It's a pub/sub library. It's good. I like it. Amqp is an advanced messaging queuing protocol. It is more commonly used. It's used by a lot of big banks and a lot of big corporate people. It is very similar to MQTT. It is 3 times larger, but that's still an extraordinary small footprint. It's like 6 bytes for a package. So if you want to implement MQTT or AMQP, though, The specifications have gotten a bit out of hand, so I'm still waiting for them to fix that. Peter Hitchens wrote an excellent blog post, a critique of AMQP, which is very, very detailed in what the problem with the AMQP specifications are. Both of these are asynchronous. Both are based on TCP and is pub/sub libraries that are really, really well to use. My normal design factor is MQTT internally inside my home network and AMQP between my home systems and services outside of my network. I'll talk more about that in a moment. So, the smaller the protocol, the less power we use. It makes sense. It takes less time that we have to wake up, send something, and go back to sleep. It's that simple. We want to minimize time, and we want to minimize the power that we need to actually calculate what we want to do up. Building HTTP strings in JSON or doing binary data. I know what C is the best at, so. Radio transmission protocols, Wi-Fi, they all support this kind of stuff. You don't have to choose like 6 Wi-Fi low pan, BLE, or whatever you choose to use. They can all support, as long as they can support TCP, you can implement these protocols over them. You can also implement them over radio systems. And a small CPU is not ideal for big protocols. It's also something you have to think about. Because the Arduino isn't a powerful processor. You can't do AMQP with SSL cryptation on an 8 MHz pro. You can do, but it will take you forever. And that is not very battery good. All right. Sorry, I've been talking a lot today. So building your own isn't always. We have to kind of like select where we start. If you know nothing of electronics, I don't think that building from scratch is perhaps the best option, unless that's what you want to do. Start with an Arduino and abstract away when you wish to learn something or something isn't good enough. But build your own IoT devices, build your own automation devices, but to not go crazy, start with modules and then abstract your way down. Okay? Next rule, design with failure in mind. So one of the most common things that people do when they start automating things is putting the processor in the middle. That's very odd. I've been to a number of places people talked about, yes, I hooked up the previous lamp controlling button to the processor and made the processor the lamp controlling process. Which means that now when my code breaks, I can't turn on the lights. Glorious. Let's say we have another option. Let's say that we make the lamp button a lamp button that sends an event to our microprocessor. Now we're designing with failure in mind. If our microprocessor dies, we lose a service. We can no longer communicate with this service. We can no longer tell if somebody pushed the button or not. But as we walk into a room, we can still turn on the lights and see if the battery is dead or whatever happened, if the dog ate the cables. Or this is useful. We can also add things to the processor to observe what everything we're automating. This means that if somebody pushes the button and the cable is out and we doesn't get the signal, but the service is still up and running because it's wireless and has battery power, it can still tell us that, okay, so we didn't get the signal, but hey, the lamp is on, so don't worry about it. I got you covered. This is also part of designing for failure. We think about how can we observe the events that we want to do in more than one way. Make sense to you? Okay, let's talk about cloud services. This is a very, very common way for people to set up cloud services. You tell your microprocessors to talk to the cloud. And then they do that. No problems, right? And then the internet goes down and you get nothing. You cannot communicate. Your apps can no longer communicate to your devices. Everything is just gone. Again, we should design for failure. So what can we do to improve this? Well, one of the things is that if we have very, very sensitive data that we want to take care of, maybe we have an aquarium, but it's very, very important that we actually store the data of the water quality or whatever we're doing. Bad example, I know, but I don't actually know when this would be good. But one of the things we can do is actually locally store data. But a lot better would be to have all the required system inside our networks and then have one point that speaks to the cloud service. Because this means that our app internally in our network can always communicate with the devices, even if the internet dies. And we can add more points that makes the internet less likely to die. For example, if the Wi-Fi dies, we can have an Ethernet connection and stuff like that. We can even add more devices. We can add security and abstractions upon this is currently my setup at home. And I'm actually, because of Azure's amazing uptime recently, I'm thinking about doing this. But again, the more you design for failure, the more you think about what can go wrong and how can I make sure it doesn't, will help you get buy-in from your family. It is a good way to make people like what you build because it's available and they can trust it. They will start using it. And as they start using it, you can build add-ons with your kids, or you can actually build. This is amazing. I've done this. You're going to love this. You can build something for your spouse, which is basically you doing your hobby, and they will thank you for it, which is lovely. Don't worry, I run a Mac. But if this would have happened, I would have had a spare laptop with this presentation on, because I designed this presentation with what? Awesome. Right, rule number 3. Out of sight is out of mind. Nobody likes a cluttered home. If you remember Todd's wife, she hated a cluttered home. She wanted neat and tidy things that she could take pictures for and put on blogs. Sure, I know people like that. I don't like them, but I know people like that. So one good thing is to actually start to think about this right out of the box. So how can we put things where people won't find them? Well, people don't see what they're accustomed to. You can buy fire alarm housings for $1 each from eBay. And I've tried this. I made actual experiments with this in the office. I put 10 in the roof. Nobody said anything. I mean, if people actually thought about it, why do we have 10 fire alarms? What are they afraid of? But we don't. People don't think about it. Your brain goes, fire alarm, nah, I ignore that. You don't think about it. People don't see what they're accustomed to. I have a friend of mine. For 26 years he had been married. For 24 of those years he had a mustache. It took his wife 2 months, to realize that he shaved his mustache. People don't see what they're accustomed to. Also, people rarely look under stuff. You couldn't sit at a public place if you did. Which means that it's a possible awesome way to put things. Put them under things. People will never see them. Now, putting something inside a wall can be tempting, because I've said now that hide things away, remove them. And you want to put things inside a wall. Don't do that, because putting something inside a wall means you will never ever get to it. It's gone. If it breaks down, that functionality is gone. Or you're going to have to remove drywall, get the thing, plaster. You're not going to do that. So I know a lot of people that does this. I don't know why they do it, but they put things inside walls and then they go, oh yeah. Also, there's a fire risk, so don't do that. You can buy these at most shops, and it's just like firewalls. If you need like fire alarms, firewalls. People won't think of them. You can't put 10 of these, but you can put one in a room, and people will not actually care that much. People won't see it. So hide things and think about it directly. Which leads us to rule number 4. Everything is a project. When you start doing something, and I'm so guilty of this, think about what you want to do. What do you want to automate, and how are you going to do it? Plan ahead. Just figure out, I'm going to need these resistors, I'm going to need this microprocessor, I'm going to need this cable, and I'm going to need this sensor, and I'm going to need these 2 things. Then order those and do your project. And you will not have an office that looks like this. But now you're thinking, okay, so learning. What if I have to try something? I don't know. I don't know what I'm going to need. Learning is a project. Buy the few things you need to actually see what you could do, and then get rid of it. You can buy things anywhere, anytime, any day. You can go out in Oslo and you can have all the things you need for a project at a day. You don't have to store it at your home. There will be times when you want to buy cheaper stuff, buy things for on the cheap. But in the end, just make it a project. Because make it small projects, because you can iterate them to big projects. And this means, and this is actually not even that complicated. Let's say you want to automate a lamp, and you do one. You do it really well. You do it really, really well. You build an app for it. You learn Xamarin or something cool so it works with all the phones that people can get. You do that well. And people will come home and say, okay, click. Oh, it worked. Nice. But people get accustomed to things very quickly. Our brain is very lazy. If we can automate things, people love that. Because our brain don't want to do things. They want to think about things. Our brains want to relax. And very quickly, you can make something that previously was nothing into a hassle, which means that people want more of it. And you can get buy-in from it. And that means you can iterate your projects even bigger. And you can still have a family that's happy about it. And you will not go crazy because you have 10 unfinished projects that you never did. How many people here have unfinished projects? Yeah, I'm in the right room. So start thinking about this way. And start involving people around you. Like, involve your wife, involve your husband. I say wife because I have one, not because I'm sexist, okay? Start involving people and start getting them to help you. And it will be so much better. So a good friend of mine, Mats, he did what Todd should have done. He's a smart man. He built this. This is the most buy-in thing. If you want to start with a project, build a magic mirror. And just make it say, I love you. Then you can do facial recognition and give personal messages to people. You can do so much with this. So if anybody doesn't know what this is just a two-way mirror in the front of a screen, powered by a Raspberry Pi. An extraordinary simple project to do that most people love. And also, it's a super useful UI. Because you can start collecting data from your home and showing it on these screens. You can start setting everything up, actually controlling them from this place. And you might get away with having stuff like this once in a while. All right, so selecting the perfect hardware platform. This is impossible. How many hardware platforms were there when did you first hear of IoT? 6 years ago. Okay, how many hardware platforms were there 6 years ago that you knew about? One. Yeah, exactly. With that, like Arduino or something like that. How many are there today? I don't think I can count them. I could stand here for 50 minutes just saying hardware platform names if I took out a list. There's always new platforms. But this leads us into something that's quite funny. This is a problem that we know about, right? Because we're developers. How many JavaScript frameworks have you seen since jQuery? Because we have learned abstractions. We have learned to remove our code so we can actually do something with it. We can actually exchange things for other things. I mean, we have the same problem set, and we can use the same solutions. We just need to decouple our hardware things and make them less necessary to handle stuff like this. So if we have an Arduino that talks MQTT, and we want to replace this with something new that we just found, the NDC Oslo Awesome Sauce IoT device. As long as it talks MQTT, the stuff around it won't care. That sounds the same, says the same stuff. I don't need this. I don't have a problem with this. So this is how I have designed my current system. So it's running on IoT Hub, Azure, and I have an Amqp queue, and I'm using adapters, which is actually the Raspberry Pis that you saw in the previous picture. I'm doing this because the Arduinos and the ESP8266 that you see in the picture aren't very good at generating SSL, and Azure IoT Hub requires SSL. And also because I want the abstraction layers. So what I'm doing here is I'm sending cryptated MQTT to the Raspberry Pis. The Raspberry Pis handle everything internally so that I can connect with my apps and stuff like that to Raspberry Pis. And then uploads to the IoT Hub with Amqp so that I can do services and consumers on the Azure side when I want to aggregate data and stuff like that and do statistical things that I want to download, but it doesn't really need to have access to should the internet go down. Because I don't think that my wife will care if she can't see the statistics on the weather or if she can't see the statistics of the showers, but I do think she will be pretty pissed at me if she can't turn on the lamps. Right? But now we're talking software architecture. And we have to think in those terms, but it is just software architecture. It's nothing new. So, always design for spouse acceptance factor. It will build a better system. Even when you're doing stuff at work, even when you're working with customers, think in these terms. What would a user that is not a techie like? How would I build this for somebody who is not like me? And we can beat all of the big players. We can beat Google and Facebook and all of those people out of the water by thinking ahead, thinking what people will use. When Google recently killed off the Nexus, was it? What was it called? The little thermostat. Nest? You know about Nest? They killed it. Killed off it. They had over 100 products that it could connect to it, but it couldn't sell it because it was a specialized product. It was an unspecialized product to people with specialized needs, and that will never sell. Keep it hidden, but accessible. Select the device most suitable for the job, but make sure that you can replace it if you need to. Decouple everything from each other. This goes for software and it goes for hardware. Design with failure in mind. And if it can't be replaced, it will be there forever. If you put something in a wall, you will never get rid of it. If you can't decouple it, it will be there forever. And in 3 years' time, you will be sorely tired of that thing. So, like software system, the end goal is scalability and adaptability. And so we want to use cloud services, but we don't want to lock ourselves to cloud services. We want to be able to access things outside of our cloud services, even if we don't have internet. We want to have decoupled systems that we can communicate with. And we want to do stuff that is nice, that we can scale out and work in iterations. Products that start small, but grows to big things that our family loves. So I lied to you previously. I said I will solve all your spare time problems. But in a way I have. Because if you start doing this, I guarantee you, you will never have a minute of spare time. But on the other hand, you will also never be bored again. You'll never ever have a bored minute of your life, because there will always be something to do that is fun, that is interesting, and that you, hopefully, with some of my advice, can bring your entire family to enjoy and to work with. All right, let's go grab a beer. Thanks for listening, guys. I have about 5 minutes left on my timer, I think. So if you want to ask a question, either come up here or just shout it out.